Today we're going to start the video kind of backwards. I'm going to show you all the parts that I've made for the mill to make it functional, and then at the end I'm going to show you some machining that I've done and some of the work that I've done for this thing. So without further ado, let's get to it. One of the first things that I wanted to do was eliminate this. This thing kept vibrating, so what I did was I put a little bit of Velcro here, just a softer part to make it a little softer, but I realized that something had to be here that I never got with this machine. There's a couple of tapped holes here, and digging through my pile of bolts and screws, I found a couple of matching screws, standard of course. So I set out and designed this part right here, and what this does is it prevents the cover from vibrating, and it also gives me mounting options for various things. So first things first, let's mount this in there. And again, this light was also added on the table. And as you can tell, this thing bolts on there pretty nicely. It's been printed with gray plastic. I designed and printed this on my PC. And this gives it a nice, even place for this cover to rest and less vibration while it's running. And the reason for the holes is I'd like to mount a dial indicator. This is an old Federal button back indicator. It's thousandths, it's not a tenth, which is enough for my needs right now. And this is a rod. It's a 3/8 rod, I believe. And what I did was I 3D printed the holes, but I reamed them with a reamer, so this thing is actually basically a press fit. And this allows me to mount the indicator to the mill, and I can indicate the table like this if I wanted to, or I can indicate the vise in this direction like that. And I 3D printed a little handle with a screw, drill and tap, nothing crazy, and this allows me to take the dial indicator out, mount it, fold it up, and I should be able to pull this out. I can only grab some leverage, and there we go. The press fit is actually very nice. It sits in there and it does not vibrate or move. The next thing is this mill actually had this crank, and the handle was not there. I didn't have a handle, and I didn't want to wait for months or weeks to get one or find one or whatever, so I made one. And the way this has been made is it's a 3D printed handle, and I made some steel bushings that kind of press in both ends. It's a piece of stud that I turned on the lathe. I turned down this 5/16 nut and a 5/16 locking nut. This was so happened to be the perfect size already to be tapped 5/16, so that's exactly what I did. And this gives me a handle that, unlike the original one, this handle actually rotates. And of course, 1/2-inch spanner, and I get a nice big handle for my big hands. I'm going to enjoy using this thing. The next thing up, which I will show machining on, is making these clamps for the vise. And the vise is a grinding vise that I want to adapt. It's a 3-inch grinding vise. I want to adapt about 80 millimeter or so. I want to adapt to this machine. So I'll show you how to mount that. With the theme of making things, I had to make my own T-nuts. And these were not too terrible to make. I made them on the shaper, and the original table here, based on the manuals that I read, is what this thing used 5/16. A lot of people usually drill them out and they mount 1/2 inch studs on there. I don't see the point of it because the slot here is just about 1/2 an inch. So basically you're running less meat here. So these were put on a shaper. What I did was I actually staked the bottoms so the studs that I've turned do not protrude out, and if I tighten this down too much it's not gonna bust the T-slot on the table. So I'm gonna slide these in, and they slide pretty nicely in there. I'll do the same thing here. As I said, it doesn't protrude out. And now I have 2 studs. This is the vise that I will be using, and the vise actually came in with an Allen key. I didn't like that too much. This is a cast iron piece that I made. If you follow me on Instagram, you've already seen this. This was late one evening. I wanted to turn something, so I turned this. Found a chunk of cast iron, knurled it, drilled a hole here, filleted it, and everything else. This is an old key. It's a US made key, by the way, and all I did was clean it up because it was rather old, and I pressed it in with my vise, my bench vise, and this actually gives me a pretty good handle to tighten down this vise. Now these were 8mm dowels that I had to turn, and of course there's 2 of them. And the way this works is they literally span 3 holes, and it's a bit of a press fit here. One side, and on the other. There we go. And the studs fit in there rather nice. The holes were actually drilled 8mm, even though these are 5/16 studs, because the fit was just perfect. And some washers and some nuts. Put the washer upside down. This is 01 tool steel, and the actual pins, they were turned down from shock absorber rods that I salvaged from my vehicle once I replaced them. And this gives me, again, common 1/2 inch spanner. It gives me a nice solid mount. Add this, and we have a nice milling machine. So I recycled some of the foam that I had around the shop, and I made this insert here. And for this I have all the milling machine accessories. This part over here needed new bronze bushings because the ones that were in there, they were wallowed out. And of course clean up and respray. This nut over here has seen better days, but it's not in bad shape. And the horizontal arbors. I'm not tightening this down to run the machine in horizontal mode just yet, but and there's a drawbar that goes in the back of this thing. go ahead and tighten it for now. There you go. And this is the holder for the ram. These have to slide out. In this case, the arbor can turn, and there's a nice fit here. This arbor stabilizer holder, whatever, this bearing block actually has 2 threaded holes in front for a piece that I do not have, that actually grabs onto the bottom of the table and actually stabilizes this whole thing from moving up and down. That's something that I may make at a later time, but one of the things that I did notice is that this hole, the bottom one, actually goes into the oil galley that this bushing uses. And what I did was I put a little bit of oil in there, let it leak in, and the bushing, even though it's a bronze bushing, or I should say a sintered bronze bushing that I turned down, which I will show after this, it still could benefit from a little bit of oil. And that's all there is to this machine. I believe this machine is now complete. There's a few modifications I'd like to add down the line. I'll surely make a video or at least mention it down the line. But for now, I hope you enjoy some of the machining content after this. And thank you for watching. Please subscribe. I have this rusty piece of tool steel. Well, I think it's tool steel. I believe it's 01. That's what it's stamped on here. And this was a hand-me-down from somebody else, so I am not 100% sure, but I'm fairly certain. And what we're going to do is we're going to start off by squaring it off. This thing has been sawed pretty nastily by some sort of saw here too. The back of it actually seems to be ground, so it's pretty nice, and this edge is not too bad, but this is going to get faced off as well. But this is going to get faced off to bring it up to a nominal size. I set up the shaper already. Make sure that we have enough stroke, which is basically the maximum stroke this thing has. Yes, unfortunately my shaper doesn't have a handle to move the ram back and forth, so you just pop open this and turn the pulley by hand, but looks like I have plenty of room here. It's basically at maximum stroke, so this is not a 6-inch piece, but pretty darn close to it. 3D printed heads on a Stanley soft blow hammer. Okay, so next up is we got to select one of the tools, and we're going to be using my roughing tool, like so. And let's see, we wanted to cut this way, or cut this way. Have it cut this way. Of course, any shaper. Okay, I think this is pretty well set up. I'm going to give it a nice tightening. Let's bring this thing back up, roll this over. So to prevent stall out on the shaper, I have to take lighter cuts. This stuff is hard, so, which is good because it's going to make a nice clamp. So I'm going to have to go through this a few times. So now we have to set these up on this so I can actually true them up. The bandsaw, actually my bandsaw leaves a fairly accurate cut. However, the end of this was never really a proper cut. It was from the previous owner's bandsaw, so I guess that one didn't cut so straight. So we're gonna set it up. A piece of paper here to give these fighting chance of gripping. And I already wiped the vise before I put these in. Sometimes getting this thing into neutral is a little tricky. Okay. And again, this is 01 tool steel, so I have to actually be fairly easy, especially in this setup where there's two pieces. I don't want anything to slide out or the machine crash. We're here at my surface plate, which is covered by leather. We're going to do some layout here, and we're only going to use the calipers because this vise, the holes are just about 8 millimeters, and these dowels that I've turned are about 7.9 millimeters, and each hole feels slightly different because I guess there's casting defects or something. So we're working out, this is where this is going to be mounted, these blocks are going to be mounted. So we're working out the distance, which is about 35 millimeters, give or take. And that's enough because these dowels will be pressed onto these blocks and they will go into this vise. So if it's within half a mil, it should be fine. Being that these are 35 minus 8 millimeters, we're talking about 27. That's the whole spacing here, and it sounds about right. The blocks themselves are about 46. So what we're going to do is I'm going to Sharpie this whole block, and they're both within hundreds of a millimeter to each other, so we're quite happy with that. Now that we have sharpied both of these, we're looking at a 9.5 millimeter. Make sure this thing is zeroed. It's close enough. There we go. So each corner will be about 9.5 millimeters. There we go. Now the height, we're going to have to figure that part out. As you can see, these dowels will happily go all the way through. I do have a dowel that's slightly oversized that gives me the ability to kind of shove it in there and not fall off. So just about 21 mil to the top of the dowel, minus half the diameter, which is about 4 millimeters. We're looking at 17 millimeters. 27. From the bottom, a little bit of a sanity check. Yep, about 17 is where we want to be from the bottom. Here we go. I'm gonna go ahead and drill these out. I'm back from the drill press, and I got 2 holes drilled and chamfered on each one of these, but I did forget to mark and drill the top hole, so that's what we're gonna do now. This is about 26 mil thick, so we're gonna go down again using calipers, so I'm not going nuts here. I'll be marking a 13 millimeter from the edge, each of these, and the width of these is 46 millimeters, so about 23. 23. Come on. 23. Oops. So we have 23 millimeter. X marks the spot. I will be using 5/16 studs for this vise, and it just so happens that an 8 millimeter hole is perfect for a 5/16 stud. So I'm going to go to the drill press spot and step drill these until I get my desired hole size. I'll be back. We're back from the drill press again. 2 holes on top, drilled and chamfered. Chamfered on the bottom, chamfered on the sides, chamfered in the back. Everything's been deburred. These blocks are now ready. I have to turn a few more of these pins that go into this vise, and I'll see you at the lathe. The pins have been turned and the blocks have been made. Time to clean up the blocks and see if it actually fits on the vise. So now we have the time-honored tradition of using a bench vise as a press. Here's the 2 clamps. They should kind of fit in there. A little tight, but actually do fit. Doesn't seem like it rocks. And the clamps should not interfere with any stock that sits on this. Now it's time to mount it on the mill.